Okay, so I'm just doing a video on your summer exam so that at the start of the year now in September, you'll be able to go back and revise some stuff from last year. It was a good sort of assessment of how much that you remember from last year. So yeah, there was 8 questions, a mix of everything that we'd done. So you got a bit of geometry there with some trigonometry, a bit of algebra and that sort of stuff, and then you also had probability there. So we'll just go straight into it. They're all more or less the same length. I gave the same marks for all of them. So let's go straight in. Okay, so first one was some coordinates. We are given 2 lines, and we've got 2 points on each of the lines, and they make a trapezium. So let's find the exact distance AB. So you've got the word distance here, so that means straight to your distance formula: x2 minus x1 squared plus y2 minus y1 squared. Coordinate geometry questions always just go straight to the formula book. Now you're given the points, so that's AB, so that's your x1, y1 on A and x2, y2 on B. So let's do the x's first. We've got 1 minus 4 squared there. Sorry, I put the squared outside. Plus then for y2, we've got 5 minus 0 squared. Okay, so 2 negatives make a positive, so you get 5 squared here, and you get another 5 squared there. So you've got 25 and 25, so you end up with square root 50. Okay, that will simplify down. You could do root 5, root 10, root 5, root 2, root 5. So you've got 5 root 2 as your answer. You can just put it in the calculator either. So root 50 or 5 root 2 are the answers there. Okay, then you're told to find the exact perpendicular distance from A to the line. Sorry, just to make sure you got that. Right, so A to the line. So this time it's not distance, it's perpendicular distance. So that's, again, another formula. So AX1 plus BY1 plus C all over the square root of A squared plus B squared. Okay, so this is a line that you need. So this will be in the form of AX plus BY plus C equals 0. So we've got our line here. It's not written like this. So we're going to need to make sure that our y gets moved over here. So instead we're going to have x minus y minus 2 is equal to 0 this side, but it doesn't really matter the side. So as you can see, now you can take in your A is the number with the x, so A is 1. Your B is the number with the y, so it is minus 1. And your C is the number by itself, so that is minus 2. So make sure that you get that right, and then you've got your point here, that's your x1 and your y1. So now just fill it straight into the formula. So you'll have so those lines are absolute value. So the absolute value of 1 by minus 4 plus then b is minus 1 times, what's y1, 0, then plus minus 2. And that's all over the square root of a squared plus b squared. So that's your 2 numbers here, 1 squared plus minus 1 squared. And then it's just a matter of figuring the whole thing out. So you've got minus 4 there. Then that will cancel out because it's just minus 1 plus 0, and then plus minus 2. So it's minus 4 minus 2. And 1 squared is 1, minus 1 squared is 1. So it's all over root 2. So minus 4 minus 2 gives you minus 6. So the absolute value of minus 6 over root 2. Which is the same thing as just 6 over root 2, which if you put into your calculator, it will simplify itself to 3 root 2. Okay, so again, it's just straight into the formula, nice simple coordinates question. Now, so you've got an exact distance, so you've got AB, and we've also got the distance from like here to here. It's like an exact perpendicular distance. That's what you're after finding out. So the next question then, it asks you to calculate the area of trapezium ABCD. Now I'd put that hint in. Actually just forget that. You can do it that way, but it's actually probably easier to do this. So we've got the distance AB, which was 5 root 2, and we've got the distance from A to the line, which was 3 root 2. Okay, so what we actually need now, the area of the trapezium, it's in your formula book. So the area of a trapezium is A plus B over 2 times h. So these are the sides, and this is the perpendicular distance. Okay, so we actually have one side here already, and we've got the perpendicular distance here. So we just need the other side. So we have AB, we also need CD. So C, just looking back at the question, was 3, 1, and D was 0, minus 2. Okay, so all we need to do is find the distance CD. So let's just use our distance formula and not rewrite it, but we've got to remember x1, y1, x2, y2. Switch colors just for it. So we've got x2 minus x1, so 0, minus 3, plus then minus 2, minus 1. So that would be minus 3, forgot the squareds, squared plus minus 3 squared. So they're both like that. So you get 9 plus 9, so root 18, which will simplify to 3 root 2 if you put it into your calculator. So now we actually have everything we need. So we need to add the two sides on the top. So we can do 5 root 2 plus 3 root 2 on the top. So that's our a plus b. And then on the bottom, all over 2. So that's in the bracket. Then on the bottom here, on the perpendicular distance, we'll multiply it by h. So that is 3 root 2. So we have that from earlier on. So we get 8 root 2 over 2 times 3 root 2. Then 8 divided by 2 will just give you 4 root 2 times 3 root 2. So you can do it, you can just stick it in your calculator, or you can do 4 by 3 is 12, and root 2 by root 2 will give you will just give you 2, and so you get 24 units squared. Okay, so you're using the two parts from the earlier bit to solve the last bit. So yeah, you can do it the two triangles way. That wasn't really that helpful of a hint. This is easier because you've already got 2 of the answers. So there is question 1 done. Right, moving on to question 2 then. So this time we have got a circle question. So again, we've got our equations here at the ready, and we just have to work some magic to try and do some stuff. So center and radius, I don't know what I was talking about magic there, sorry. So center and radius, remember the center comes from these things, and the radius is the square root of g squared plus f squared minus c. So centers come from that, so you switch the signs and you get half of it. So for C, if we switch the signs, we get minus 2, and so half of that is 1, and 2 is your center. And so for S, then our center will be 4 and 6. So switch the signs and get half of them, or get half of it and switch the signs might be the quicker way. Okay, then just moving on to the radius, then you get the square root, so it'll be 1 squared plus 2 squared, and then it'll be minus whatever the third thing is. So it'll be the opposite sign of that. So it'll be 1 squared plus 2 squared, it'll be minus minus 4, so obviously that will make a plus, 2 squared. So we've got 1 plus 4 plus 4, so that's the square root of 9, which is just 3. So we've got our center 1, 2, and our radius 3. And for this one then, we've got our center 4, 6, and our radius will be 4 squared plus 6 squared minus 48, so 16, 36. So to add those together, you will get the square root of 4 when you do that on your calculators, which is of course just 2. So very easy, center and radius. You should be able to do those fairly quickly. So now you're told the circles touch externally. So that means that the circles need to be sort of vaguely like this. You know, they're just touching each other in one place. So that means that the radii, so the radius is added. So that, you know, think about this first distance here, should be equal to the distance between the points. Okay, so if you think about it, I should probably zoom in a bit here. So look at 2 points. You've got one radius and another radius, and you've got the total distance. These two things should be the same answer to show that they just touch in one spot there. So we just have to get the 2 radii. So we've got 3 plus 2, so the radius is 5. That's nice and simple. Now the distance between the points, or distance between the centers, might be a better way to phrase it. The distance between the centers. So distance formula, same as in question 1. We've got x2 minus x1 squared plus y2 minus y1 squared. You should really know that off by heart if you can. So x2 minus x1, so x2, y2, x1, y1. I'll just keep these up there and not bother rewriting them. So we've got 6 minus 2 squared plus 4 minus 1 squared. So 4 squared plus 3 squared, that's 16 plus 9. Don't forget our square root is still here the whole time. So the square root of 25, which is 5. So as you can see, they are the same. So they touch externally. You probably should put a conclusion in. Sometimes they don't accept the answer if you haven't put the conclusion in. So just write a conclusion properly. So you can see how, again, just like in the first question, you're using stuff from one part to get the answer to the next. So make sure to fill in everything you can. Now, point A52 is a point on the circle. This. So that big equation, show the k is minus 6. Okay, so the fact that you're showing the k is minus 6 probably implies that you need it for something. And I was just telling you the answer. You don't actually need k down below. But anyway, so remember, every point is x, y. So you see you've got an x and you've got y's. So any question like this, you just lash this in as quick as you can into wherever it's supposed to be. So you see 5 will be x, so you put that in there, and 2 will be y, so you put that in there. So let's get going from there. So x squared, so we've got 5 squared plus y squared, 2 squared, then plus k times 5 minus 2 times 2 plus 5 equals 0. Okay, and all of that simply to get your answer. So you've only got one variable, so that's nice and easy. So you've got 25 plus 4 plus 5k minus 4 plus 5 equals 0. Then you can just do the nice thing of adding your like terms. 25 plus 4 is 29, minus 4 is back to 25, plus 5 is 30. So you got 30 plus 5k equals 0. Let's just move our 5k over there. No, I probably should have moved it 30. Makes no difference anyway. 30 equals minus 5k. And then you can do it in your head or divide by minus 5. And you will get 6 equals k. So you see, it's subbing in and then just solving a linear equation. Right, that's a fairly nice question. Often circle questions have that. Something to do with a point in an equation. Just sub it in and hope for the best. Okay, this one, I gave you a hint. It was a simultaneous equation. So get x or y by itself and sub into the circle equation. Okay, you won't always be given these hints in the exams, but yeah, so hence find the intersection circle. Oh, you do need it. I said you don't need it. So one circle up above here is x squared plus y squared. Then k is, sorry, that should be a minus 6. Minus 6. So minus 6x minus 2y plus 5 equals 0. So that's just rewriting it from the question above. So you do need that. Now, remember, you get x or y by itself and sub it in. So here, it's easy to just keep x by itself. So let's just take these two things and lash them over there. So that will give us x equals y plus 1. Okay, these simultaneous equations, this is always the approach that you want to take. So that means everything we've got a y plus 1 for x. So that means we can plug a y plus 1 in there and a y plus 1 in there. So just everywhere you see x, change it to y plus 1. So you get y plus 1 squared plus y squared minus 6 by y plus 1 minus 2y plus 5 is equal to 0. Right, so there's a lot of multiplying out here. So remember y plus 1 by y plus 1, or y plus 1 squared means the bracket twice. You should be able to multiply it out. You'll get y squared plus 2y plus 1 down there. And then these terms will keep going. So then minus 6y minus 6 minus 2y plus 5 equals 0. So now just gather your like terms. So we got our y squareds. So let's get 2y squareds. Then you'll have plus 2y minus 6y minus 2y. Okay, those two pluses will go, and then you get just minus 6y. And then you get plus 1 and a plus 5. So that will give you plus 6 is equal to 0. Right, so you see we've got our squared thing here. So we've got a quadratic equation. So let's just divide it by 2 to make life easier. We've got y squared minus 3y plus 3. That'll leave it a lot easier. Then we can just use our guide number. So our guide number is 3. It'll have to be 1 times 3. Oh, let's see. That does not add to minus 3, does it? Where have I got it wrong? I'm afraid you're just going to have to listen to me because I've already done all of this. And I am not willing to just do that, to just get rid of it all of a sudden. 6y minus 6. Oh, I forgot my minus 6. That was careless. Let's just go back off that. Apologies for that. So you see you have got minus 6 here. So this plus 1 plus 5 minus 6 will give you 0. So let's just go back to there. So we've got 2y squared minus 6y equals 0. Yeah, I was wondering it wasn't the right thing. Anyway, you'll get 2 by y minus 3. We'll just factorize it, equals 0. So we get, we get 2y times y minus 3. Now my head is gone. I will pause after this and make the video. Now, this is only question 2. I have to keep going. So we've either got 2y equals 0, so that would mean that y has to be equal to 0, or y minus 3 equals 0, so y is equal to 3. So those are your two options, but then remember we have to take our x equals y plus 1 and bring it down here. So we will sub that back in. So if y equals 0, x equals 0 plus 1, so x equals 1. And if y equals 3, then x equals 3 plus 1. So x is equal to 4. So there's your 2 points. You've got 1, 0 and 4, 3. So those are your 2 points of intersection. So it's between, see the way it's a circle and a line? So like you can imagine, it's like this. So there's 1, 0 and 4, 3. That's what you're after solving. Apologies for the mess up in the middle of that. But hopefully you were able to follow it regardless. I'm just not redoing the video. You can tell I'm a professional, can't you? So let's go on to question 3 then. So question 3, I'm going to do the video in 2 halves. I'm not going to talk through all 8 questions, but I'll do 4 and 4 just for convenience sake. Right, so question 3, it's kind of functions, and we've got a bit of ease there, so that means you're going to be thinking of logs. So make sure to go to the indices and logarithms page in your formula books if you need it. So anyway, first off, you don't need that. So it's just f5. That just means to sub in 5. So you've got a function. It's defined like this. You just need to sub in 5. So f of 5. So you see 5 has replaced x. So we've got 5 minus 1 over e to the power of 5. Okay, and then all you have to do is put that into your calculator and you will get 4.9933. So that's a very easy start off there. And then you want to find the value of the limit as x tends to infinity of f of x. So essentially, you've got 5 minus 1 over e to the x. Okay, as x goes to infinity, 5 won't change. So 5 is just going to stay as it is. Then this here, so let's imagine that this is e to the power of infinity. Or let's think e to the power of 99999 and keeps going on. Okay, that will become basically 0. It'll become very, very close to 0. So as x tends to infinity, then 1 over e to the power of x will tend to 0. Okay, so sorry, that won't turn into 0. That will turn into an infinitely big number. So that's a massive number. So this will become basically 1 over like so many 9s that it won't be relevant anymore. So this will just basically become 5 minus 0 at that point. So the limit as x tends to infinity is just 5 minus 0, which is 5. Okay, so that's that one finished. So the limit is 5. Right, so solve the following equation. So it might look like what on earth is going on here, but you realize that there's an fx here, there was an fx up here. So you just have to use that down here. So let's just zoom back in so I can actually write. So you'll have 5 minus 1 over e to the x is equal to 1 over 5. Okay, and you'll see your form will have to be ln something. So remember, ln is the same thing as log to the base e. So just remember that. Okay, so we want to get rid of fractions. Remember, we hate fractions. So we want to multiply everything by 5e to the power of x, because that would be the denominators together. So we will multiply both sides by times 5e to the power of x. So you will get, from that, you will get now 25e to the power of x here, then minus 5 is equal to e to the power of x when you multiply all that together. Now we've got something that vaguely resembles a linear equation. So let's minus e to the power of x from both sides, and let's plus 5 to both sides. And that should work things out nicely. So we get 24e to the power of x equals 5. Right, and let's try and get x on its own. So let's get rid of this 24. So we'll divide both sides by 24. And we get e to the power of x equals 5 over 24. So you're very close here. Now remember the rule that says log base equals answer to the power. So we've got base to the power is equal to the answer, and log base equals answer to power. So we've got our a and our p here, and we've got, so that's b, base to power, and we've got our answer. So we can do log e, so that's log to the base, and then we've got our answer, so that's equals, log e 5 over a equals p. I've done that wrong. So log ba equals p. So log to the base e 5 over 24 is equal to x. Now, we have got a fraction here. So remember, log to the base e is the same thing as ln. So we just have to use our thing. So it's ln a minus ln b. We just use the fraction for that. So we've got ln 5 minus ln 24. If you look at your formula books, that's how it works, is equal to x. Okay, so that's that one sorted out there. Sorry, I stumbled over my words a bit there. Okay, so that's that one done. Now we've just got one more equation left to do on question 3. Okay, so looking at your formula book, you will see that these have the same base and then different things here. So, and an add in the middle. So when they're added in the middle, you're going to multiply them. So check your formula books for that. So it'll work out as log 2, and then x plus 2, x minus 2 equals 5. Right, again, we've got our log ba equals p thing going on here. So, and then we've got b to the power of p equals a. So we're doing the same thing as we were in the last question. So we've got our base here, we've got our answer here, and we've got our power here. So we've got 2 to the power of 5 equals x plus 2, x minus 2. Okay, so 2 to the power of 5 is 32, and we've got x squared, then it'll be minus 2x plus 2x, so they'll just cancel out, and then minus 4. So x squared minus 4. Okay, let's just solve it now, nice and easy. Plus 4 to both sides, so we've got 36 equals x squared. And then you want to get the square root of that, And so we have got x equals 6, but don't forget it could also be x equals minus 6 for that question there. So yeah, you have to check your formula books for the rules of logs. So when they're added, you're going to multiply them. So if they've got the same base, the same base and they're added, you're going to multiply them like this. If they were minused, you'd have to put them as a fraction. So anyway, that's that question done. Is that question 3 or 4? Okay, question 4, and I'll stop the video after question 4. I think I've been going quite a while. So this is a calculus question. So we've got a function and we've got it as a fraction. So as soon as you see a fraction in a calculus question, so f prime of x, the derivative of fx, this means you're going to need the quotient rule for this question. So we will work with that now. So the quotient rule is, so we've got the top is u and the bottom is v. So make sure to go to your formula books and it'll have it in a fancier form. But basically the way that I see it is v times u minus u times v all over, sorry, that is not exactly it, right? It is v times du, so v du minus u dv all over v squared. Okay, so the best way to do this out is to just do u equals x squared minus 1 and v equals x squared plus 1. Okay, so the d just means derivative. So the derivative of u, so du equals 2x. So remember, you take the power down and you drop it by 1. So it's just 2x to the power of 1. And then the constants just go. And then, so dv, the derivative of v, is going to also be 2x because the constant will just go. So now let's just fill it into our quotient rule. So we've got v, which is x squared plus 1, times du, which is 2x. Then we minus, then x squared minus 1 times dv is 2x. And then the whole thing is over v squared. So that's x squared plus 1 squared. And you don't need to multiply that out. Right, we just need to simplify it out a bit. So we will get 2x by x squared. So we get 2x cubed plus 2x minus, and that'll be x squared by 2. So minus 2x cubed, and then minus 2x with a minus there. So it'll be plus 2x. And then all over the bracket squared again. I'm just going to leave it that. X squared, sorry, squared plus 1 squared. Okay, so let's just simplify that. So you see the x cubes will cancel out and you will get 4x over x squared plus 1 squared. Okay, so that's all in the formula book, this rule. Right, so that's part A. Now let's go to the next function. The function is defined for x is a real number by this. Find g prime of 0, the derivative of this, for x equals 0. So that just means you have to find the derivative first and then sub in 0. So let's do this together now. So 3e to the power of x actually won't change derivative wise because e to the power of x just differentiates to e to the power of x. So g prime of x will just be 3e to the power of x. And then minus sine x will differentiate to minus cos x. Again, look at your formula book and you will see the rule there. And then the plus 5 will just be gone. So now we just need to do g prime of 0, which is 3e to the power of 0 minus cos of 0. So 3e to the power of 0 is just 3 times 1. So that's just 3. And then cos 0 will be 1. So g prime of 0 is just 3 minus 1, which is 2. Okay, nice simple question there because the terms are all separated, so you can differentiate them separately. Right, so you've got a hence, so you need the answer. Okay, hence find the equation of the tangent to the curve at the point where x equals 0. Give your answer in this form. Okay, so remember, derivative is the same thing as the slope at x equals 0. Okay, so to get a tangent, we want an equation. So that's y minus y1 equals mx minus x1. Okay, so we have now our slope, which is 2. So that's our slope. but we also need the point at 0. So we need to just get g of 0, not g prime of 0, because we have our xy is 0 comma something. So we need to sub in for 0 up here. So it's 3 e to the power of 0 minus sine of 0 plus 5. So just stick that into your calculator. You will have, it'll be 3 minus 0 plus 5, so it'll be 8. So our point is 0, 8 is our point. Now, it can be just easy to forget that step, that you've got your slope up here, but you also need the point. So you need a slope and a point. So let's just go in with this. We've got our m and we've got our x1, y1. So let's just sub it all in. Y minus 8 equals 2x minus 0. Let's just sub it in. Y minus 8 equals 2x. And you want it in the form plus equals 0. So let's just move these over here. So we'll get 0 equals 2x minus y plus 8. Doesn't matter what side the 0 is on, it's grand. So 2x minus y plus 8 is your answer. That's the equation of the tangent. So you can imagine there's a curve that looks like that, and that's the tangent there, touches at 90 degrees. Right. Oh, and there's two more parts to the question here. So we've got the product rule. So again, the product rule, you've got two parts, u and v. So we've got u equals x squared, v equals tan x. And the product rule is basically u times the derivative of v plus v times the derivative of u. So we've got u, let's get the derivative of u, which is just 2x, and the derivative of v, which is just going to be sec squared x. Again, these are just in your formula book, so look at them there. They're ones that you can just remember. So let's do it into the rule now. So u times dv, it's kind of like a crisscross thing you have to do. So we get x squared times sec squared x plus tan x times 2x. So we need to find the derivative. So remember, the derivative can also be written as dy dx, just to remind you. So we get x squared sec squared x plus 2x tan x. Kind of a meaningless thing, but that's just showing that you're able to use the product rule. And now to finish off, we need to differentiate something from first principles. So usually that's actually part I of a question. I must have stuck that in at the end. So from first principles means that you can't just get the answer. So you can't just go like, oh, so you got the 2 times the 5, which is the 10x, and then you get rid of the x, so it's just 10x minus 7. So that should be the answer that we get. But first principles means you get the limit as h tends to 0 of f of x plus h minus f of x all over h. So basically you're trying to get 2 points that are so close together that there's no distance between them, and you're getting the slope of that point. So anyway, you have to get f of x plus h. That just means sub in x plus h. So that's 5 by x plus h squared minus 7 by x plus h. So that'll be 5 by x squared plus 2hx plus h squared minus 7x minus 7h. Just multiply it out. 5x squared plus 10hx plus 5h squared minus 7x minus 7h. Okay, it's a bit of effort, but we get through it. So you got all these things, but then you are going to want to minus f of x off it. So we will need to minus 5x squared minus 7x. Okay, so it'll be a minus 5x squared and a plus 7x. So you'll see what happens there. That'll be 5x squared will be gone with that, and a minus 7x will be plussed off with that. So what we end up with on the top of our thing, so don't forget to include the limit sign, h tends to 0, we'll have 5h squared plus 10hx minus 7h all over h. Okay, now we can get rid of this h on the bottom because it'll cancel out with everything up there. And so we get 5h plus 10x minus 7. But don't forget, it's the limit as h tends to 0 of that. So this is going to be 0, so bye-bye. And you will get 10x minus 7, just like we had up there. Okay, so I think this has been fairly long. I am going to stop at that because it's been long enough. Sorry about some of the messed up bits, but hopefully that's helpful, and I will make a second one at some point for the rest of the exam. Okay.